Let's see what range of values does Gini impurity lies between. In the previous video, we have seen for what range of values does entropy lies between. We have seen that entropy lies between 0 to 1. The minimum value will be 0, the maximum value will be 1. Similar to entropy, Gini impurity also refers to impurity. It is also one of the measures to compute the impurity. Gini impurity is defined as 1 minus sigma ranging from I is equal to 1 to k of probability of I whole square. Here also k refers to the number of classes in the classification settings. So in order to define the range of values for the Gini impurity, let's again consider two different cases. One best case scenario and one worst case scenario. So under the best case scenario, I'm considering a pure node. Again, what is a pure node? Whenever all the samples in a node belongs to the same class, we call that as a pure node. Whenever all the samples in the node are equally distributed among the two classes, we call that as an impure node. So now let's try to compute the Gini impurity for both these cases, for both the best case and worst case scenarios. So first, let's try to compute the Gini impurity for the best case scenario. So here we have two classes. So this sigma will range from I is equal to 1 to k. So I'll write this as 1 minus. First, I'll compute the probability of I whole square for the positive class. That is number of samples in the positive class by total number of samples. So this will be the probability of I whole square for the positive class. For the negative class, it will be number of samples under the negative class by total number of samples. So this will be for the negative class. So if you break this down, we'll get the value as 0. So as you can see here, the node is very pure. So it's obvious that the impurity will be very less. So similar to entropy, the minimum value for Gini impurity is also 0. Okay. So now let's consider the worst case scenario. So here, let's calculate the Gini impurity for the impure node. So where I'll compute 1 minus. So total number of samples in the positive class by total number of samples in the positive class plus negative class. That is 60 plus 120 whole square plus, again, for the negative class probability also, it is 60 by 120 whole square. Okay. So again, if you break this down, we'll get the value as 0.5. In entropy, we have seen that under the best case, we got the entropy as 0, and under the worst case, we got the entropy as 1. Whereas for the Gini impurity, under the best case, it is same, the value is 0. But for the worst case, it is 0.5. Okay. So now if we try to plot the same thing in the graph, so instead of the values ranging from 0 to 1, under the Gini impurity, the values will range from 0 to 0.5. Okay. So under the pure node cases, that is these two extremes. So whenever the probability of being positive is completely 0, or probability of being positive is completely 1. In these two cases, the node will be very pure, so the impurity will be 0. And under the worst case, that is when all the samples are equally distributed among the classes, so we reach to this probability where the Gini impurity will be very high. That is the maximum, that's 0.5. And again, if you try to compute the Gini impurity for different probabilities, such as like 0.25, 0.45, 0.75, 0.85, we'll get a smooth curve like this. Okay. So that's all about Gini impurity range. Thanks.